function notation, hopefully you have seen this before, but it's just f of x. And the f of x, f represents the function name. X is our input, and y is our output. So f of x is equal to y. Basically what we're doing here is we're replacing y equals equations with f of x equals equations. So f of x is equal to y is how this is written. Just a word of caution, this is f of x. It does not equal f times x. It's not, parentheses here do not mean multiplication. At the side we have just a visualization of what's happening here. We're taking our input of x, we're substituting it into our function machine, which is our equation, and then we're getting an output of y. Couple examples. Here is our function. It's function g, so this is g of x is equal to negative x squared plus 4x plus 1, and we want to find g of 2. So that means our input is 2, or our x value is 2. So we're going to input that into our function, and a lot of times I like to write this new function before I input anything is wherever there was an x before, I want to put in a set of parentheses. And after I do that, I'll put in my input of 2 so I can see exactly where that input is going. And then all you do is simplify. So here we have 2 squared, which is 4, and take the opposite of it, so that's negative 4. Plus 8 plus 1, and our output is equal to 5. So this is saying g of 2 is equal to 5. That's equivalent to the point 2 comma 5. Next example, g of 3x. So this is saying our input is 3x. So again, I'm going to write my equation with parentheses of where my x used to be. And then I'm going to input my new value, which is 3x. And then I'm going to simplify the right-hand side. So 3x squared is 9x, and then I want to take the opposite of that, so I get negative 9x squared plus 12x plus 1. And we usually don't write it this way, but this still does represent a point. The x-coordinate, or the first coordinate, is 3x, and then the output is negative 9x squared plus 12x plus 1. And in our last example, same type of thing. I'm going to write this with my parentheses, and I need to make them a little bit bigger because I have the expression t plus 2 to fit inside there. Okay, and then I'm going to simplify my right-hand side. And again, I have to square first according to the order of operations. So this negative is just going to have to wait until I square this. So this ends up being t squared plus 4t plus 4. And then I'll go ahead and distribute my 4. On my next step, now I'm going to distribute my negative. And then I combine like terms, and the resulting answer is negative t squared plus 5. So g of t plus 2 is equal to negative t squared plus 5. Okay, let's take a look at this graph, and this function is function h of x. And we're going to look at the graph and see if we can figure out the domain. So it's helpful, since these are points, to figure out the coordinates of all of our points, and then that's going to tell us our x and our y values. So let's go back. The first point is negative 9, 2. Second point is negative 4, negative 3. Our next point is positive 1, negative 3. Next point is 6, 2. And our last point is 11, 6. So question A, state the domain. We're going to write this as a set. So our domain is x such that x is equal to, and we're just going to list out all of our x values. We're not going to repeat any, and it doesn't look like any are repeated, and then list them in numeric order. So the first one we're going to have is -9, -4, 1, 6, and 11. So there are all of our values. Then evaluate this function at x is equal to 1. Well, just look at your graph and look at the x value of 1, which is right here. We go down and we see that our y value is -3. In terms of writing this out, this would be h of 1, because it's telling us our input is 1, is equal to -3, which is our output. Or you can also list it as a point 1, -3. Okay, determine the value or values of x when y is equal to -3. So this is saying h of what x values are equal to -3. So now we're going to go back and look at our function. And here's -3, and if you look, we have 2 points that have a y value of -3. So our answers are x is equal to -4, x is equal to -4, and x is equal to 1, or you can list out those points. And then the next question, state the range. So now we're looking at the y values for all of our points. So range y such that y is equal to, and again we're going to start down here at the bottom, and we see that our first value is -3, and there are 2 points that have that, but we're only going to list it once. Our next y value up is at +2, and then our last y value is at +6. So we only have 3 values of the range. Last thing we have is average rates of change. So for a function that is smooth and continuous, on the interval containing x sub 1 and y sub 1, the average rate of change between x sub 1 and x sub 2 is given by this equation, the change in y over change in x, which are subtracting the y coordinates and dividing by the subtraction of the x coordinates, and we should be familiar with this because this is the slope. More specifically, it's the slope of the secant line, but all we're looking at here is finding the slope between the 2 points.